Hey guys, we're going to try solving inequalities. It's the same as equations except for a few minor changes. The first thing is, do you remember these? Do you remember the different signs? The one that everyone mostly gets confused is the ones that say or equal to. Or equal to. Remember, this just means that I could say, that -4 is less than or equal to 8. Or I could say that 8 is less than or equal to 8. It's still a true statement. Now, do you remember how to graph? That's the question, isn't it? So, the key here is if you have the or equal to, you have a closed circle. As you can see, the closed circle on 0. If it is not or equal to, like this one, you have an open circle at -2 here. Then it's just deciding which way does the arrow go. And it's really important that you just read what it says. So, in the first one, it says x is less than or equal to 0. So that means it's true for all the numbers that are less than 0. So my arrow is going to the left. For B, it says x is greater than -2, which means it's true for all values that are greater than -2, which means all the numbers to the right. My arrow goes to the right. For C, x is less than 1. So it's true for all numbers that are less than 1, so I draw my arrow to the left. And for D, x is greater than or equal to -1. So it's true for all values that are greater than or equal to -1. The only way that we show the or equal to part is by the open or closed circles. So if it's or equal to, it should have a closed circle, which means -1 could work in this equation or inequality. Now, I want you to take a minute and pause this video and write your own rules and reminders for graphing on a separate sheet of paper or in your notebook.
I have to record this.
Welcome back. All right. So for the first one, I think the best thing you could have written as maybe open circle. Same for the next one. And then I would have written closed circle and closed circle. You could have written more things. You could have written the words like less than, greater than, less than or equal to, greater than or equal to add more to your rules. This is the big one. The only difference between equations and inequalities is that when you multiply or divide by a negative, you have to flip the inequality sign. This is the big, important idea you need to remember when you're solving inequalities. It's only true for inequalities, and it's only when you multiply or divide by a negative number. Now let's try. All right, our first example. We still draw our line. We circle our variable. We can do change, change, and now we solve. It's like a two-step equation. You just have to bring down your inequality sign. So the first one, I would do add 3 to both sides because it's furthest away from the variable. I cross these out. I bring out 2x equals 3 plus 3 is 6. Is less than or equal to 6. And now I'm going to divide by 2. So that means that x is less than or equal to 3. Now I could graph it on this number line. I could put, okay, here's 0, here's 1, 2, and 3. I see that it's got the or equal to, so it would be a closed circle on 3. And x is less than or equal to 3, so it's all the numbers that are less than 3. And I can draw my arrow to the left. Next example. Alright, this example, again, I draw my line, I circle my variable, I do some change. What's furthest away is the 2. 2 is positive, so the opposite is to subtract 2 to both sides. I bring down negative 3y is greater than 16 minus 2 is 14. And now I need to divide by a negative 3. What happens when I divide by a negative 3? That means I have to flip the sign, as you can see I just did. And then 14 divided by negative 3 gives you a negative 4.6 repeated. Or you can leave it as a fraction if you want to do that on your calculator and mix it, that's totally fine. This example, a little bit more complicated. We're getting to the variables on both sides, things that we've been doing. So again, I can draw my line. I'm going to do some change. I'm going to combine some like terms on this side first, so I'm going to bring down everything else. And negative 7 plus negative 16 equals negative 23, so I'm going to put plus negative 23. Now I want to bring my variables to the same side, so it's easier to subtract 2v to both sides. I bring down the 11, the greater than sign. I get 2v plus negative 23. Now it's just a two-step equation or inequality. So I can circle my variable. I'm going to add 23, continue my line. These go bye-bye. I'm left with 2v, greater than sign, and we have 34. I'm going to divide by 2, which means I'm dividing by a positive number, which means I don't flip the sign. I get v, and then 34 divided by 2 is 17. And that's my answer. Again, I could graph this. I might go up by 5s to graph this, slower, up by 2s to get to 17 before, and I wouldn't want to make a number line all the way to 17. But this is read as we start with the variable v is less than 17, so be careful when you are graphing. Last example I want to talk about. So we draw our line. I can do some change here, and I need to do distributive first. So I have 8y plus, and then 4 times negative 1 is negative 4, greater than negative 7 plus 2y. Now I can bring the variables to the same side. So I'm going to subtract 2y. I'm left with 6y plus negative 4 is greater than negative 7. Now it's just a two-step inequality, so I'm going to add 4 to both sides. I'm left with 6y is greater than negative 3. I'm going to divide by 6. Because I'm dividing by 6, it's a positive number. Again, I don't flip the inequality sign on this one. Just because there's a negative in the problem doesn't mean I flip it. So I am left with y is greater than, and then this one, it might be easier just to leave it as a reduced fraction, which if you know 3/6 is reduced to 1/2, so it's negative 1/2. And there's your answer. Be ready to work in class, and don't forget to complete the form.